The main purpose of today's discussion is to understand the surge protection, and this surge protection is different from the surge control. So let's start the discussion. Surge protection. Surge control takes away compressor from the surge, but surge control doesn't trip the machine. If the surge is not controlled due to frequent surges, then surge protection trips the compressor. Final discharge pressure is taken as input data for the surge protection. Although there are other parameters can be taken and logic can be developed for the surge protection. However, discharge pressure is the best in other options. Location of discharge pressure transmitter PT should be very close to compressor outlet to capture the correct pressure variation. If pressure transmitter is installed very far off, pressure variation is not captured and so surge protection is not effective. Pressure transmitter is taken into PLC. PLC is the best where surge protection system is developed. However, surge protection is also developed in DCS, which is not so effective due to larger scan time. So you can see it is a multi-stage compressor, and surge protection is also applicable to even single stage compressor, and it is air compressor or process compressor, and one anti-surge valve is installed. It is venting to atmosphere in case of air compressor, and it is recirculating back to suction in case of process compressor. Then final discharge, one pressure transmitter is installed very close to final stage for measuring the pressure, and then discharge side one NRV is installed, and then discharge valve, and it is connected to discharge header. Surge slope. Let's say it is a flow versus differential pressure. Surge starts from B1 and pressure drops to point C1. So you say B1 to C1 in the performance curve. The surge slope from B1 to C1 is negative. So slope is negative because pressure is down. Surge returns from point C1 to B1, C1 to B1 during the surge cycle, and the surge slope is positive. So if pressure rises from C1 to B1 is considered as a positive slope, and from B1 to C1 is a negative slope. A1 B1 is A1 B1 and A2 B2 are on performance curve for minimum and maximum inlet guide vane position. So this is for minimum inlet guide vane position, this is for maximum inlet guide vane position, or it can be other IGB positions, or it can be also different speed of the compressor for the variable speed compressor. Pressure variation of A2 B2 is more than A1 B1. You can see A2 B2 and A1 B1, which indicates that higher IGB position surge pressure variation is more than minimum IGB position. So of course slope variation, surge variation is more in more IGB position or more speed. Although positive slope and negative slopes are created during the surge, however, in this surge protection philosophy, only negative surge will be considered. Points B1 and B2 and C1 on the surge curve where slope is 0. So you can see the time versus discharge pressure graph. B1 and B2 and C1 all are the where slope is 0 because it is parallel to x-axis or time base. Surge slope calculation. Surge slope is calculated through regression methods. How we can calculate? Let's say P0, P1, P2, P3 points are there where pressure is bar gauge 10 bar, 9.5 bar, 9.25 and 9 bar. Sample time is 100 milliseconds, so every 100 milliseconds all data is captured. So you can use the equations 3 into P3 plus P2 minus P1 minus 3 into P0 upon 10 into T. T is the sample time. It will give the bar gauge upon millisecond. So it is coming minus 0.00325. So slope is calculated how? Pressure unit into factor upon time in second. Pressure unit can be bar gauge, kg per cm square, etc. And time is second. Factor can be 100 or 1000, etc. So slope calculated using these three data, all four data is coming as minus 0.00325 bar gauge millisecond. To convert in bar gauge second, you have to multiply it 1000. So surge slope is equal to minus 0.00325 into 10 to the power 3, which is equal to minus 3.25 bar gauge upon second. Now factor is 100. So surge slope with factor will be slope into F, which is minus 3.25 into 100, which is coming as minus 325 bar gauge upon second. Surge slope calculation. Slope is calculated for 4 set of points at interval of 100 millisecond. If new point is added, the last point is removed, and so slope is calculated with 4 points with addition of one new point and removal of last point. This keeps on calculating at every 100 millisecond interval. You can see here 4 points, then last this is removed, new is added. This, and likewise for another last is removed, then this is added, and keep on doing. So every time 4 points are available for calculation of surge slope. Surge test data shows that if the inlet guide vane is more, then discharge pressure slope at surge condition is also more. You can see more the IGB position, slope is also increasing. Discharge pressure slope is selected for IGB minimum position, where compressor can develop required discharge pressure without surge. As at higher IGB position, slope is more, so compressor is protected with selection of lower slope. In this case, let's say minimum IGB is 30%, so slope selected is minus 1018 bar gauge per second. Surge protection set point. Surge test slope is minus 1018 bar gauge selected for the minimum slope, minimum IGB. Let's say safety margin 10%, so minus 1018 into 10 by 100 is minus 102 bar gauge. So surge protection set point will be, set point is equal to minus 1018 minus 102, which is coming minus 916 bar gauge per second. So control time, it is a time when surge slope value is considered. It is activated when surge slope is less than the surge protection set point in magnitudes. Let's say minus 916 is set point, then moment it becomes minus 915, it will start activated. Surge count, it is numbered when the surge slope less than the surge protection set point, and next surge count will be considered when the slope becomes positive and then become negative and less than the set point in magnitude. So total surge count is considered during the control time. Surge protection logic, let's say control time is 60 seconds, surge alarm for surge count is 2, surge trip for the surge count is 4. So condition 1. When the surge slope is less than the set point value in magnitude, one surge count is considered and control time of, let's say, 60 seconds is started. During control time there is no more surge count, means slope is not less than set point. There will not be any surge alarm and control time will reset automatically. Condition 2. When surge slope is less than the set point value in magnitude, one surge count is considered and control time of say 60 seconds is started, and during the control time if there is one more surge count during the control time, then total surge count will be 2, and in this case there will be surge alarm and compressor will be unloaded. Condition 3. When the surge slope is less than the set point value in magnitude, one surge count is considered and control time of say 60 seconds is started, and if during this control time there are 3 more surge count during the control time, then total surge count will be 4, and in this case there will be surge alarm and trip both, and compressor will be trip. So thank you. I have finished my lecture. Hope you like this. If it is so, please subscribe my channel, like it and share it so that you will get the intimation of new video. See you in the next discussion. Till then, bye bye. Thank you.